Alrighty, my friends. So today we are going to go over the Pythagorean Theorem. Does anybody know what the Pythagorean Theorem is? No? Okay. So, the Pythagorean Theorem, my friends, it is more algebra than anything else, honestly. But because it incorporates a shape, it is in geometry, obviously. So the Pythagorean Theorem. Let me draw something out for y'all. Let me draw this. Can somebody please tell me what shape that is?
Triangle.
Perfect. And if I drew that right there, can somebody tell me what's the specific name of this triangle?
Right angle.
What is it? Oh yeah. Right angle, right triangle, a right triangle. Reason being is because of that little section there, right there. If you look, that's pretty much a 90-degree angle. Okay? 90-degree angles. We see that around us everywhere, right? The corner of every paper, of every board, of every wall, there's a 90-degree angle, right? So the right triangle versus other triangles, such as that, or such as that. I mean, they're all triangles, but this one in particular that we're dealing with today is called the right triangle. And it's very unique because if you were to be given a question like this, it's the famous one that everyone's aware of. If you're given this and then that, the question is, what is the... Okay, let's say side A, which is where the 5 is at, has a height of 5 feet, and the base over there has a length of 6. What is the distance of the missing side? When you are asked, and pay attention, when you are asked to find the missing side of a right triangle, no, not the area, no, not the perimeter, no, not the volume, everything that we're going to be hitting this week and next week, I'm not asking about all that. When you are asked to find the missing side of a right triangle, your brain should immediately go to the Pythagorean Theorem. Alright? What is the Pythagorean Theorem? The Pythagorean Theorem is just a formula. We learned about formulas last week or 2 weeks ago. I forgot what it was. Remember, it's a little template for us filled with variables. You throw in the numbers in for the variables. You calculate it. You push equals. And then that gives you whatever it is that you're looking for, right? Well, the Pythagorean Theorem is exactly that. It's a formula that when you punch in what's needed and you solve what's needed to solve, you will find the missing side of the right triangle. That formula, my friends, is the famous a squared plus b squared equals c squared.
And then you square root c.
At the end, yes. But we'll get there. This is the most important part, knowing what the Pythagorean Theorem is. It is a formula, and the formula is a squared plus b squared equals c squared. So here, how about we solve this one, my friends? I think this might come out as a decimal, so get your calculators ready. I'll get mine. So, the thing is, think of a right triangle always like this, A, B, and C. A, B, and C. Honestly, A and B never really matters. It could be B and A. It doesn't matter, but I've come to the realization that students like memorizing A is this part and B is that part because they like thinking the B is base and it stands for bottom, right? But it really doesn't matter in terms of the math. As long as you know that the part the sides that actually touch the 90-degree angle, as long as you know that those are side A and B, you're safe all the time. And as long as you know that the long part of the right triangle, the long part is C, you're safe. That long part has a name. Your side C has a name. The long part of a right triangle is called the hypotenuse. The hypotenuse. So now comes the joke. Does anybody know, has anybody seen the show Key and Peele? Key and Peele, there's a little episode. But that's irrelevant at this point. Let's continue on with math. So, A, B, and C. A, B, and C. So tell me, my friends, just like we did last week with the slope of a line formula, we just have to get our numbers and put them into its designated spot. What's my A?
5.
5 squared. Plus, what's my B?
6.
6 squared equals, and that is what we're looking for, my C. I am looking for the hypotenuse in this specific case. So just like last week with the slope of a line formula, once you've inputted your formula with the designated data, guess what we do? We solve. Using equations, using whatever the case, we just solve. Is there anything I could do here? There's a lot that I can do. Let's do it step by step. Well, what's 5 squared? Plus, what's 6 squared? I was thinking 8 squared for some reason. I was about to put 64. Equals C squared. Okay, we're close, we're close. 25 plus 36, what is that? 61 equals my C squared. So you just found your C squared. Does it make sense to put 61 there? Does that make sense? This little triangular shape has a height of 5 feet and has a length of 6 feet. So the diagonal is 61 feet? No, do you guys know why? It's because you just found C squared. You just found C squared. 61 technically is this part over here. Alright? If you just look at that little spot, that little equation there, 25 plus 36 equals 61. Right? That makes sense. The thing is, I want to find the root. I want to find my original A, B, and C. That's what I'm looking for. I want to look for the C. I want to look for the number when you multiply it by itself. When you square it, comes out to 61. That, my friends, is why the last step always, when it comes down to the Pythagorean Theorem, is to square root it. The square root of 61 is what? That's when you get your trusty calculator. You put in 61, and then just like we learned the week of powers and roots, the calculator tells us that there is no square root of 61, right? Well, that's what the calculator thinks. So then we're just like, forget you, calculator. Convert this weird number, this weird square root, and give me the long decimal. And what we end up getting is 7.810249676. Obviously, we round it to whatever it is that it tells us. Let's pretend we're told to round it to the nearest tenth. So the final answer is 7.8 equals my C. So 7.8 is my hypotenuse. Square root. Square rooting is always going to be your final step to look for the c squared, or in the next couple examples, the a squared or b squared. So let's do another example. This time I want everybody to watch out for the tricks that these type of Pythagorean theorem problems might give us, and the different just styles that they might give it to us. So for example, let's say we're given this. Let me just do something very quick. Let me get that. Let me spin it around. Boom, boom, boom. So, this, my friends, is a right triangle. Why? Because of that little corner over there. So if they give us something like this, well, let's say they're given a word problem. It doesn't really matter, right? When you see this, majority of the times your mind should be like, oh, they want me to find the missing side of this right triangle, which means the Pythagorean theorem. But let's say we added a word problem, such as the shape below shows the blueprint of where 3 light posts are going to be placed in the neighborhood. So this is an actual aerial view of a neighborhood, and it just shows a map of the 3 locations. 1 light post is going to go there, there, and there, right? The distance from 1 light post to the next is 7 miles. Not light posts. How about telephone poles, right? Satellite, I don't know, right? 7 miles from one side of the neighborhood to the next. And then from here to there is 8 miles. What is the miles from this point to that point? Labeled with the X. It doesn't matter how they give it to you. It doesn't matter what unnecessary word problem they give you. Look at it. Look at the diagram, and your mind should immediately say Pythagorean theorem. Because even though they're talking about distances here in the word problem, even though they're talking about miles and this and that should never throw you for a loop. You should see it and immediately know you're looking for the missing side of a right triangle here. So, what's the Pythagorean theorem? A squared plus b squared equals c squared. But the other thing, the word problem might not just be the only thing that trips you up, but the way they, kind of set up your diagram could trip students up. Tell me, what's my A?
8.
8 or 7, it don't matter. What's my B?
7.
7 equals my c squared. Because sometimes you do have to twist your head around, or you could just look at it. Again, always keep in mind the sides that meet at the corner of your 90-degree angle, that's your A and B. So in this specific problem, they are, again, just like the last one we did, they are asking you to find the hypotenuse. All they did was place the right triangle on its side. Now you're probably questioning right now, are they ever going to give us the C? Are they ever going to give us the hypotenuse and ask us to find the A and B? Of course, which is our next example. But for now, let's knock this one out. Now that we know, now that we've set it up, let's solve it the way we did the last one. What must I do first? Tell me. What's 8 squared? Plus 7 squared equals my c squared. What's 64 plus 49?
113.
113?
Yeah.
I trust you. So 113 is your square root. So tell me, 113 is your c squared. What's your last step that you always got to do?
Square root.
You got the square root. So tell me, what is the square root of 113?
30. there isn't one, so you gotta convert.
There isn't one that the calculator dishes out for us, so we put the convert button. And what we end up getting is, let's round up to 10.6 equals my C. If you haven't noticed already, the long part, the long part of the right triangle is not only called the hypotenuse. Well, yeah, its name is the hypotenuse. But the other thing you got to look out for is, if you're looking for the C, it better be a bigger number than either your A and B, because that's exactly what the hypotenuse is. It's the longest part of the right triangle. So if you do some sort of math, and this comes out to being 7.8, you know something went wrong with your math, because this long part should be the biggest number between the two. Yes?
So, will they ever ask you what the whole distance?
So, that's one example of how they might trip you up with word problems or a triangle flipped on its side. You have to literally twist your head sometimes just to really visualize what your A, B, and C is. There's obviously another way that they might give us Pythagorean Theorem problems. Let me see if I still got the skills to do this. That was bad. Okay. So.
Is that like cauliflower or broccoli or something?
I think it's very apparent that this is a tree casting a shadow. So the thing is, here's a word problem for y'all, right? The word problem is 10, 12. Okay. So here's the word problem. Some genius out there, for some strange reason, found a tree casting a shadow, decided to connect a string or a rope from the top of the tree to the corner of the shadow. And the measurements that he or she took was that string or that rope that they had to connect to the tree and to connect to the end of the shadow measured 12 feet. It was a 12 feet long string. He then measured the distance from the shadow to the tree. Measured a distance of 10 feet. The question is, how tall is the tree? How tall is the tree? Well, in this specific problem, there isn't a full-fledged shape. We don't see a very nice triangle, a right triangle. But again, this is the ways that Pythagorean Theorem problems might be thrown at you. Which is, it's your job to know that this triangle, if you really look at it, or this word problem I should say, is technically a right triangle problem. They gave us this, they gave us that, and all I'm looking for is the height. This is a standard question in most state assessed tests and whatnot. The famous tree or the famous ladder next to a wall, right? That's just famous Pythagorean Theorem problems. It forms a right triangle, and it's your job to see that. So, if you've just determined that this is a right triangle, if you just determined that you need to locate the height, if you just determine that you will be using your famous a squared plus b squared equals c squared formula to solve this, how about we solve it? Tell me, what is my a?
12.
Ha! So, this is the beauty. In this specific problem, They've tricked us. They gave us our C, my friends. Remember, the C is the hypotenuse. It's the longest part of the right triangle. This is where the 90-degree angle meets. That's the angle part. That's the diagonal. That's the longest part. They gave us our C. They gave us our C. So guess what? You do have your C. A and B, well, it doesn't really matter which one is which. So you could literally put 10 for your A or 10 for your B. It doesn't matter. But no matter what, it's your job to know that either your A or your B, that's the one that's missing. That's the one that they are asking for. So yes, sometimes they might give you the C, and it's your job to find the A or B. Again, it doesn't really matter which one's which. Either you did this or you did this.
C squared minus A squared.
Hold on, I'm getting there. Or you did that. It didn't matter because A and B, again, never really matters as long as you put them in either of those two slots. So, you've just determined that they gave you the C. You've just determined that you have to locate either the A or B. You decide. How do we do this? My friends, you do this via equations. Remember that little thing we learned 3 weeks ago? The thing that's crept up constantly? Equations is key to solving missing variables. And we're going to be doing a lot of that in geometry. So you use equations, which means you split the lines. Tell me, is there anything I could simplify here? Yes, I don't know what A squared is, but I definitely know that 10 squared is 100. Then you go to the side B. Is there anything I could solve there? Yeah, 12 squared. What's 12 squared?
Wouldn't that be
What is it?
Wouldn't that be 140 or 144?
144. So now tell me, how do I leave A squared by itself?
Subtract 100 from both sides.
This is a number. It wants to be far away from the variable. It wants to be over there with its buddy. So what? The 100 needs to be moved. How do you move it? By subtracting. You subtract that, and then A squared equals, what's 144 minus 100?
44.
44. So, again, what is the last step that you must always do in Pythagorean Theorem problems?
44.
So we square root 44. What do we get? 211? That cannot be right.
Oh, 2 squared is 211.
Oh yeah, but I mean, that's the calculator doing its thing. What should we always do?
Convert
Simplify it.
6.6.
So A is actually 6.6. So you just found the missing height, which is 6.6 feet high. Equations, my friend. This is a straight up simple equations. You're majority of times always going to subtract this side over there, square root it, and then be done with it. You'll see that it's a very straightforward 1-2 process. It's really simple. The hardest part is this first part. Not accidentally putting the 12 in for A and then looking for C. That's going to be the thing that you want to try to avoid. Because then you're wrong. Whatever number you just came up with, it's for something else. That's the hardest part, is determining when your word problem is asking you to find the A and B, A or B, and they've provided C. And I don't mean tough as in tough. It'll be very clear. Either they give you a picture or they tell you, like the way today's worksheets are going to be laid out. Either they give you a diagram like the one I just drew, or they give you something like this. Leg A, leg B. I don't like my lowercase b's, so I'm just going to start using capital letters.
Even in your bubble letters?
Article what?
Hypotenuse. So either they give you this, and I don't know, 10, 13, and then the question mark, right? So here in this specific case, they didn't give us no diagram, but it's very clearly laid out for us, for you to draw out. Right triangle, the hypotenuse is the long part, so that's obviously C, that's my question mark. That's what I'm looking for. Leg A and B never really matters, just do that, and then go forth, my children, right? So either they lay it out like that, either they give you a little picture, and it's your job to see the right triangle within the depicted picture. No matter what, these are going to be the processes that you use. If they didn't give us like this, and they gave it to us like this, how's my diagram going to look like here? Well, in this case, they gave us the hypotenuse, A, and question mark. This is how majority of the worksheet today is going to look like. And you're going to use the Pythagorean Theorem, aka a squared plus b squared equals c squared. Any questions before I hand out the worksheet? Good.